So let's look at decorators. Before we reach the point of decorators, let me just cover some base concepts around it, and then I will explain what are decorators. So we will not start with the definition of decorators, but we'll understand some concepts building up the thing, and then we'll get to decorators. So the first concept around it, around which decorators are based is functions are first class objects, or sometimes people say they are first class citizens. The simple meaning of this statement is that functions are objects, and if they are objects, they can be stored into a variable, they can be stored in a data structure, they can be passed as arguments to another function. You saw we passed operator dot add recently in the iterator thing, right? You can pass them as arguments to functions, and functions can return another functions also. So functions are normal objects. So to prove that point, there are some small snippets. We created a function here and we are storing it in a variable, and using that variable we are calling it. So that's possible. You can have a list also. Let's say you have a list of func, and maybe you create it empty and then you say list of func dot append xyz, and because I don't have any other function as of now, I will append the same function again. Okay, and then I will print the list of func. It's a list having two function objects. Okay, and I can run it. I can say for f in list of func call f. So that xyz is called twice. So functions can be stored in simple variables, in data structures, everything. And functions can be passed as arguments. You can have functions which take a function as argument and then do something on that. So this little snippet is not doing much. It's just calling that function and just printing that I'm calling that function. So this another function is not really doing much, but it calls that function which is given as a argument. So let's run it anyway. And it calls fn. And what was fn? Fn was display, and display is this print hello. So I can see that I got this print calling function, and then that display which was passed as a argument. This fn is equal to display, actually the same as display because display is passed. Fn is a reference to display, you can say, or fn and display are references to the same function object, you can say. So we successfully passed it to a function, and that function did something. It called it. It could have stored it in a variable also. That's fine. Now the third thing, functions can return another function also. Okay. So here this another function takes fn and returns the same function. It's no utility, but it's just demonstrating that I can return a function. So when I say ret is equal to another func display, this ret will become display only because another func, when it gets called, fn becomes display and it returns fn. So ret becomes display only. So calling ret is equivalent to calling display, which will print hello. That's fine, no big deal, but it conveys that I can return a function. I can take argument as a function. So this whole little thing which we saw summarizes to say that functions are first class citizens for first class objects. That's fine, no big deal. Then when we understand decorators, we need to understand concept of a wrapper function. Decorators are not exactly wrapper functions, but they are very close to wrapper functions. Okay, so what is a wrapper function? So let's say I have this function which does something. It performs something. So a wrapper function, you can understand it as a wrapper function which obviously does whatever fn does, but it does a little more. It does a little more than that. Okay, so it wraps the function within it, and it does a little more than the fn does. So let's see an example. Although this is a dummy example, but let's see. Let's say this I have a function which does some processing, whatever it is some processing. So a wrapper function will be something like this. So it will say, I mean, if I say a wrapper function, ideally I would say, yeah, I mean, so what is this wrapper function doing? It is ultimately calling func only. So it is doing whatever func was doing. Maybe to make it realistic, I should have some two parameters here because it is called with two parameters. But never mind. This wrapper function is doing whatever func was doing, but it is doing some little more before it, some little more after it. Maybe it is even changing the arguments passed to the function. So it is wrapping it within it, but it is now uh, doing a little more before calling the function, after calling the function, while calling the function, maybe it changes the argument. So it wraps it and it creates some value added functionality for the user. So this tiny this code is runnable. This much will run. If I call that function, then I will start facing problem because these names are not defined. Do something before, do something after. But this thing is runnable. It is correct, and all symbols are resolved here. So it's just printing before and after. It's not this wrapping is not doing much. It's just printing before and after the hello. When I call the wrapper function, I get hello, but I get before and after. So in that sense, some sense you can visualize that I am getting a value added thing. I'm getting what the wrap function was doing plus a little more. So that's okay. Wrapper functions, they are very close to how decorators work. So that's fine. That's fine. Now let's see another concept, inner functions. We have seen it earlier also when we saw those scopes, local, enclosing, global, built-in, LEGB. So we have seen inner functions, but inner functions are very much a pillar of how decorators work. Decorators actually work by creating a inner function and then returning that inner function, which looks a little surprising that you create an inner function and you return that. So because one may imagine that this inner function dies when this code executes, but if you return it, it kind of it lives. So that's inner function. So before I come to inner function, any question till now? Okay, so let's see this little code. We have a function outer, it takes one parameter x. Okay, great. We have a function inner, which takes a parameter a and returns a plus x. That is also correct. No big deal. We created another function. Now you may be returning. Now what we are returning here is we are returning inner itself. Notice we are not returning inner 10 or inner x. We are not doing that. We are returning inner itself. Okay. So that means we are returning this function object. Okay. We are returning this function object. If we returned a call of inner, that was a easier thing, and inner, let's say if we return like this, it would be easy to imagine inner 10, so 10 plus x. That's easy to calculate, and you will be returning an integer. But we are not doing that. We are returning inner, and inner means this object. Now, the magical thing is that when you return this inner object, it remembers what was the value of x. It, it remembers what was the value of x. Okay. So because you can really understand it like it remembers the value of x. I will indicate how it remembers the value of x, but it remembers the value of x. So that means you can do something like this. You can say add 100. Add 100 is just a variable name. You can call it x also. Outer 100. So if I call outer 100, then finally it will return a function. It will return a function which does a plus 100. Okay. And if I call outer 200, then it will return a function a plus 200 and so on. Okay. So basically you can understand that with every invocation, let's say I invoke outer with 100, it generates a function inner where x was 100 and returns that function. Next time I call outer with 200, it generates this function inner where x is 200 and it returns that function. So those two are different functions. So let's demonstrate it. So this is, in some sense, you can call it as a function generator, if you like that term. Okay, it returns a function, and every function is different in the sense that it remembers the state of arguments or even some local variables if you had uh, some variable and maybe you were using that. So it will remember that also, whatever those values were at that instance. But typically, that is may not be done. So anyway, so let's just see this closely. So let's see this print. Print at 100. That's a function object, and you can really see the outer dot locals dot inner at this. Okay. And what is the type of add 100? That's a normal function. And if you call add 100 with some value, it just adds 100. So now I can generate a add 200 also. Add 200 outer with 200. So, so let's see. Add 200 adds 200. And if I say ID of add 200, so, or let me say print add 200. And in the same code, I will say print add 100 also, so that I can compare. So it says outer or local dot inner, but you see the addresses are different. Addresses are different. And if you ask the IDs, add 100, ID add 200, they are also different. So the simple way to visualize it is that when you code outer with 100, this code executed. What that code did, it created a function definition. In that function definition, x was 100. So this is one object which got created. When you call outer with 200, it generated this function where x was 200. It remembered that yes, x is 200. So that was a different function. So in that sense, add 100 and add 200 are two different objects. So that even kind of strengthens the belief that functions are objects with a state. If they are not objects, where can you store these value of x and other local variables? Okay. So in some sense, those are stored in that object that I was in this context. The variables were such, and that it remembers. So this inner function, this little thing is very close to a decorator, although we have not come to the definition of decorator yet. So the only important point is that inner functions can be returned first thing Okay, it's not that they are local variables and they will die and hence they cannot be returned. They can be returned, just like you create a list within a function and you return it. Similarly, you can create a function within a function and return it. Second, the inner functions remember the context. This x is not a part of parameter, but this x will be remembered when you call that inner function in any context, in some other scope. It will remember that x is 100 or x is 200. These are the only two takeaways. So that's fine. Uh, of course, we are returning an inner function. We are not calling the inner function. If we call an inner function, it becomes much easy. So you finally get some computed result. That's fine. So uh, so let's see the same outer inner thing, but I have just renamed it. It's more or less the same thing. It's like the function, the outer function is get adder, and x is the offset. Maybe offset is a better name. I will rather change it. And so get adder gives me a function that add offset 100 or 200, whatever. And then adder just returns that. It is actually the same, exact same thing. And then you call add 5, add 10. It is the same exact thing, add 100, add 200. So, so we have seen that and it works also. And they are different objects and they work. This add 5 remembers that I was programmed to add offset 5. And add 10 remembers that I was programmed to add offset 10. Why? Because add 5 was called with this 5 and this 5 was the variable offset or x as we saw above and it remembers. Now consider this function, this utility function. So let's see what is this doubler. So the input to doubler is a function. Okay. Doubler takes a function as a input and the return value or if you want to say output is also a function. It returns some function. Inner is a function. Okay. Basically, doubler is that kind of a thing. It takes a function and it returns another function, and the another function will compute twice what the original function would have done. Okay, that's the doubler. So you can really imagine doubler as so this doubler. It takes a function f1 and it returns out a function f2, and f2 is twice f1 kind of. It whatever f1x is, f2x will be twice f1x. So that's fine. And let's see how it works. Let's see. So it takes a function and it defines a inner function. And in the inner function, it calls the original function and multiplies 2 with it and returns it. And now it claims that my inner function will do double the task as the argument function was doing. And let's see it in action. So we created a function fn1 which was just adding 10, and then we created a doubled fn1. So doubler is like a function input, function output kind of thing. It takes a function and it returns a function. So I say doubled fn is equal to doubler fn1. Okay, so let's run that. And type of doubled fn1, obviously that will be a function. If I say print doubled fn1, that's the inner function. So it prints it in the very similar manner. Function doubler within the doubler dot locals dot inner. That's fine. And if I say double function one with 1, so let's compute it before running it. Fn1 on 1 would be 11 and doubled Fn1 that would be 22. You can also visualize it as something more, that Let me type of this. It takes f1 and then it returns a wrapper function over f1. If f1 was this, let's say f1 was this circle, it returns a wrapper function over f1 like this, you can understand. This you would agree because in our inner code, you can understand this inner is nothing but a wrapper function over f1. Okay. It takes a function and returns another function which is a wrapper over the original function, and that wrapper is adding some functionality. That wrapper is decorating the original function with some new features. Okay, and this doubler is actually a decorator. Okay, this doubler is formally and uh, syntactically, semantically, in all aspects, this doubler is a decorator. Okay, this is a decorator. And what this decorator did, it took a function and it decorated with it with some functionality. It said my decoration or my feature addition is doubling. So I double it like that. And decorators are exactly this kind of schematic diagram. They take a function and then they create an inner function which is a wrapper over the original function. Wrapper you have seen. They can do something before it, something to the arguments given to the function, something to the return which the function gave, and they can do something after the function has executed. They can kind of wrap it in all aspects. So this doubler is a decorator, and normally you will not see uh, this kind of syntax. Normally, the syntax you will see is at doubler. You will recognize decorators. They look like this at doubler. And now, if you do that, and if you say fn11, okay, let me run it. I get the same 22 thing. So normally decorators are used in this fashion. That I have created a decorator. Now I will apply it to any function. I will say that decorate this fn1 with doubler, and I might say if I have a fn2 and fn2 was returning a plus 1 just like that, and maybe I want to decorate that also doubler, and then I can say so I have decorated both of these. Okay. So that is the beauty of decorators, because decorators you can see that they are like feature enhancements, but once you define it, you can decorate multiple places without any effort. I didn't have to do much. All I have to say is okay, doubler. I have to say doubler. Just that. So decorators are in that sense they are used. And when I say this add doubler, what exactly happens? We just want to understand what is this add doubler fn1. What does it mean? So let me comment this. This line is commented. So that add doubler was doing this thing actually. If you execute this statement, fn1 is equal to doubler fn1, then this statement is equivalent to add doubler. Okay. So when you decorate it, when you decorate a function, what are we saying? We are saying that this function is decorated with this decorator. So that means this one fn1 would change. So how will fn1 would change? Fn1 would be equated to what the decorator returned taking fn1 as input. So fn1 is transformed. So decorators are in a way you can understand as transformation on functions also. So this add doubler is just a convenient shorthand on fn1 equal to doubler fn1. So if I run that, I still get 22 and it is the same thing. But obviously, given a choice, don't confuse people. Always use add doubler. That's much convenient and much intuitive to the eyes and everything. And decorators are nice. You can apply them multiple times. And if you have a little below, I will have tripler also. But never mind. If I have doubler, I can provide it, apply it two times also. And if I apply it two times, then I should get 44. That's fine. And when I do add doubler, what I'm actually doing is this. I decorated it once, and that result I decorated again. So if I comment these two and I run this line, I get the same result. Okay. So the simple fact I'm telling is decorators are function transformators. They take a function and they return a transformed function, which is a wrapper. And the convenient syntax is this. But you should know the internal nuts and bolts that they are actually meaning this statement. So now here we have doubler and tripler. So tripler, all we have to do is we have to create a function which does triple what the basic function does. So just that. And then you can have a chaining of decorators. Just a vocabulary terms, sometimes these inner functions are called as closures. That is also a formal text term. They are closures. So in some sense, they remember the enclosing scope. So this I think is easy. Inner, tripler, chaining of decorators. And we have seen this also, that chaining essentially means that I call that decorator function again and again. So this is equivalent to this. That's okay. This is fine. Now, one more slightly more complex thing, but sometimes you may say, I want to decorate with the argument because I have just like we have doubler, tripler, and then somebody may say, I want to multiply by 4, I want to multiply by 5. So why can't I have that multiplication argument, multiplication factor, a argument? So then you can create decorators which take an argument, which take an argument. And if you do that, then you can use them in this syntax. You can say multiply 10 and it will result in multiply by 10. You say multiply by 100, then it returns multiplied by 100. So that kind of is a good thing. You can see that it's good. Uh, Instead of doubler, tripler, we are giving it as a. So sometimes you will have decorators. Multiplier is a decorator which takes argument. Sometimes you will have. But then things become a little more complex. Then that means that multiplier, because we know that this add multiplier 10 basically means that multiply 10 function 1. So basically what it means is that if I give multiplier 10, that should return a decorator, something like that. So the function becomes a little complex because till now you had seen that decorators were taking a function as input and were returning a function as output. That was okay. But now you are saying take some other thing as argument, multiplier. Then it becomes complex. But it doesn't become much complex. What it does is it takes that argument as that factor or whatever argument you wanted to parameterize the decorator. It takes that as argument and it creates a decorator within it. So this whole highlighted thing, whatever is highlighted, you will realize that it's a decorator. It's a decorator because it's taking a function as input. It's creating another function which is a wrapper on that function, and that wrapper is doing just multiple into that function return and returning. So this is a decorator. But multiplier, in a way, you can understand that it generates and returns decorators. So multiply 10 is a decorator and you decorate it like that. So if you have to create a decorator with some parameters, you will have to do some such thing. You will have a further level nesting. Earlier there was one inner function and you had the decorator and inner function. Now the decorator itself is nested in a external function. So now we notice that the inner function calls the decorated, I mean the wrapped function or the input function, right? So the inner function should know what are the arguments of the function to be called, and it should comply to that rules, whatever those rules are. So one way, if you want to decorate any function in the world, let's say you want to create such a decorator that it should decorate any function, then you can assume that the function under consideration is taking these arguments, star args and star kw args, because any function, right from the function taking no arguments to a function taking lot of keyword and positional arguments, all functions match this signature. So with that, we are seeing some decorated myprint decorator something. We will see. So myprint is just a function which prints these arguments. No big deal. It prints args and kw args. That's fine. Now we are creating a decorator prefix stars. What this decorator should do is it should print star before my actual function. Okay. So you can see that what this inner function does, it prints star. How it is printing star in 240 means repeat star 40 times. And then it calls the function with the ditto arguments, whatever it was, and then that's it. So so here I'm creating the decorator, and now this decorator can decorate any function in the world. Any function can be decorated with add prefix stars, because if I have a function display one which takes two parameters, I can decorate it and I will see this decorated output. If I have a function which takes five arguments, I can decorate it. I will see that nice output. And if I have a function which takes arbitrary arguments, I can decorate that also. No big deal. And it works, right? So the simple thing is, trick here is, if you know the parameter of the decorated function, the function under consideration, then okay, if there are fixed number of arguments. Otherwise, you can take help of star args and star kw args. So further, this demo just creates a postfix stars which prints it after the function. So that's a postfix decorator, and of course, you can use it at both places. Add prefix, add postfix. You get star both before and after. You can use them multiple times. So that's no big deal. The only value thing of substance demonstrated here is that if you want to wrap any kind of function, wrap star args, comma, star kw args. So now it so happens that normally when we call off decorators, we only imagine functions having inner functions and they return the inner function. And there also we visualize that those inner functions are actually objects and somehow they are remembering the state. You can have a explicit class decorator also. You can say this class is a decorator. This class doubler is a decorator. You can think of it that way. If you have to think of it that way, then you have to think like this. You have to think like this, that when you do fn2 is equal to doubler fn1, then fn1 is a function, but fn2 is a class object. Okay, fn2 is a class object, and that fn2 when you call, because you know objects can be callable. If an object implements underscore underscore call, it's a callable thing. So that function will, uh, that object will kind of wrap the thing. So I will demonstrate how it works. So when we do this doubler, and when we say invoke the constructor simply stores the function within a variable. It's a doubler object, so it stores that, okay, I have to uh, return twice as much as this function returns. Okay, it just stores that function, and when you call that object, it simply calls the underlying function which it had stored in the state, and it returned twice of that. And the moment you use the star args and star kw args, earlier we our doubler were very much restricted. They took only one parameter in our earlier implementation. But if you do this star args, star kw args, you can have a doubler of multi-parameter function. So you can see it's a simple thing. You store that function, whatever you are doing, and then you when this object is called as if it is a function, you invoke the wrapped function and you do a little more. So the same thing. Now here there is no concept of inner function. There is no that kind of complexity, but explicitly we are storing and wrapping and storing the state. So let's create a class and let's run this cell also. So you will see that what is the type of fn2? That's a doubler object. If I say id of fn2, that is a doubler object, and it's not the doubler class. A doubler class object is separate. When I call the constructor, I will get a instance object. Okay, so that's a different. And now fn2 actually is a misnomer, if you like to say, but it's in a way correct also because it's a function, a functor object. Some people call it functor object. Okay, so fn215, it does the work, and of course you can use the same things, and you can use the same syntax. You can use, obviously no one likes to use this kind of syntax, so you will use the at doubler, that familiar syntax. So you can do that, and even then if you ask what is the type of fn2, you will be able to recognize that it's not a function, it's a object. So those are class decorators. They are less seen because function decorators are somehow more common. But they also exist, class decorators. And the simple thing they exploit is that objects are functions. Like if you implement underscore underscore call, so object is like a function, it's a callable.